As for the introduction, atmospheric greenhouse gases have increased over the past 30 years. Average global temperature has risen by 0.2 degrees Celsius per decade. So the ocean absorbed most of this heat, raising the global sea surface temperature by negative zero point 0.4 degrees Celsius since the 1950s. So the ocean warming has led to the greater stratification and reduced the mixing in some ocean layer. So temperature increase is uneven across the different regions of the ocean. So the increased meltwater and ice discharge from glacier impact ocean current, local climates, and marine biology.
Over 70% of global fish stock have been overexploited by industrial fisheries, significantly altering fish community and marine ecosystems since World War II. Overfishing combined with climate change shift fish population in size, structure and distribution, impacting food chain and ecosystem stability. Conservation effect Conservation efforts should address both climate and fishery impact on the marine biodiversity, aim to identify the areas of highest conservation priority within our planet's marine environments, identify conservation priorities by analyzing marine biodiversity, climate change impact, and fishing pressure at local, region, and global scale.
Okay, so for materials and method in experimental design, this research utilized a specially explicit method combining remote sensing information on environmental factors such as sea surface temperature, chlorophyll, and marine currents with biodiversity and fishing data across various marine areas. Second, a grid system was created to measure the diversity of fish, marine mammals, and seabirds, enabling the identification of areas with high biodiversity. Plus, statistical models were used to analyze the relationship among environmental changes, fishing pressure, and biodiversity, allowing the identification of regions that are most impacted by climate change and human activities. So, for example, Food and Agriculture Organization of the United Nations (FAO) is the only institution that maintains and provides long-term global fisheries statistics from the 1950s and onward.
Okay, second method is a statistical analysis. Data on sea surface temperature, SST, chlorophyll, and water speed were analyzed to track global changes over 3 decades. Annual chlorophyll composite and monthly SST over current data averaged annually were used in a pixel-watch linear regression to detect significant trends. Slope, magnitudes, were standardized and combined into a cumulative impacts index. 0, no change, 1, maximum change, to identify areas with the highest environmental shifts. Okay, then we have the information on the global distribution of vertebrates. Distribution data for 2183 marine vertebrates, species 12729 fish, 124 marine mammals, and 330 seabirds were mapped onto a 0.5 grid to calculate species richness. Spatial maps were combined and standardized to create a biodiversity index, 0 no species, 1 maximum richness, highlighting spatial variation in marine biodiversity. Hotspots were identified as areas above the 95th percentile, focusing on regions with high biodiversity in major oceans. And lastly is the changes in landing of fish over the last 60 years. Fish capture data from 1950 to 2013 were analyzed to identify trends in marine resources used by country and fishing area. Using linear regression, the study highlighted nations with high captures, especially in biodiversity hotspots, shedding light on human impact on ecological sensitive regions.
So for the result discussion, the first is temporal trends in SST, chlorophyll concentration in ocean currents. Cumulative impact index shows distribution of environmental changes uneven, with poles and tropics experiencing significant shift. Magnitude of change most pronounced in Arctic and tropical regions, causing notable warming and oceanographic feature shift. Changes in northern regions, North Sea and Labrador current. Warming due to Atlantic waters, increasing SST and reducing chlorophyll values. Arctic influence, warming is corroborated by freshwater influx from melting sea ice, reducing Arctic nutrient supply according to Behrenfeld et al. 2006. South Atlantic Ocean Basin. gradual reduction in marine productivity in South Atlantic with special variability according to Boyce et al. 2010, increases in chlorophyll recorded in southeastern and southwestern Atlantic, SST variability, slight warming in temperate zones, cooling in southernmost waters near Tierra del Fuego and Antarctica. Significant rise in water temperatures around Australian continent, according to Wu et al. 2012, due to warmer East Australian current. Changes in ocean circulation. Global thermohaline circulation slowing, influenced by disproportionate heating at poles, decrease in Labrador current speed linked to decline in North Atlantic marine productivity, according to Smitiner 2005. South Atlantic gyre deceleration affecting Brazil and Benguela currents, and Malvinas and Antarctica circumpolar currents. Tropical changes in ocean currents, including increased speeds in equatorial countercurrent and reverse trends in north and south equatorial current. The second one is relationship between environmental stresses and marine areas of high biodiversity. Biodiversity hotspots. Analysis based on distribution of 1,729 fish species, 124 marine mammals, and 330 seabirds. Six biodiversity hotspots identified globally, primarily in the southern hemisphere, which are Central Western Pacific, Southwestern Atlantic Ocean, Western Indian Ocean, Central Western Pacific Ocean, Southwestern Pacific, Oceania, and Central Pacific. Concentrate in temperate and tropical regions of Atlantic, Indian, and Pacific Oceans. Environmental changes in biodiversity hotspots. All identified hotspots have experienced environmental perturbation. Central Western Pacific and Southwestern Atlantic have seen significant changes, with local to regional increases in SST and chlorophyll. Southwestern Atlantic has seen a large decrease in SST over the past 3 decades, possibly linked to natural climate variability. In remaining hotspots, SST has generally increased, but chlorophyll and ocean circulation remain relatively stable.
The environmental stresses and human activities that can give impact toward the marine biodiversity is the impact of climate change. Environmental stresses, especially ocean warming, affect marine species through altered primary productivity, trophic disruption, and shift in species distribution. Changes in water temperature and pH can lead to coral bleaching and desertification of tropical marine communities. Altered ocean circulation impacts productivity and food availability, with diverse effects across different regions and species. Secondly, intensified fishing pressure. Industrial fishing in biodiversity-rich areas, especially in the Indian and Western Pacific Ocean, threatens marine ecosystem. Advancement in technology and rising demand have led to overfishing worldwide. Countries like China and Peru led in global fishing, with many coastal nations also heavily fishing in these biodiversity hotspots. Third, need for sustainable fishing policies. National and international policies are needed to promote sustainable fishing and reduce the impacts of climate change and overfishing on marine biodiversity. Fishing practices and policies vary widely among countries, especially within EEZ, where states control marine resources. Fourth, data limitation. Limited data on fishing, especially artisanal and subsistence fisheries, make comprehensive analysis difficult. This study offers a framework for assessing human and environmental impacts on marine ecosystem, which could be enhanced with more detailed data. And lastly, it will be called for international cooperation. Due to the global nature of these issues, the author emphasized the need for international collaboration to protect marine biodiversity hotspots. This approach mirrors to the global efforts required to address the causes of climate change, underscoring the need to work beyond individual national interests.
In conclusion, the study highlights the impact of climate change on global marine biodiversity hotspot. The uneven distribution of environmental changes in Earth ocean underscore the need for conservation efforts in regions like the North Sea, the North Pacific Ocean Basin, and the South Atlantic Ocean Basin. The overlap of marine biodiversity hotspot with areas of intense industrial fishing activity emphasize the importance of sustainable fishing policies. Overall, this study provides framework for identifying areas of special concern for the conservation of marine biodiversity in the face of climate change and human fishing pressure.